Hey love, I finished your video. You need to watch all of the videos. I'm going to give you a quiz on the unmath related things that I mentioned and said. So you're going to have watched the video. I don't answer the question you sent me, but I work out so many examples. If you can't answer the question you sent me, you're going to go with your father, because I can't even, literally. I'd be lying if I didn't tell you that I had no idea how the fuck to do this until I had to tutor you. I usually solve this by going 4, 5, 6, 7, 8, 12, 16, 20, 24 until I get to the... It takes me like 1 whole minute instead of the 5 seconds I will take now with this method that I just learned. I'm glad I learned it. But I understand why it gives you trouble and understand that I have had trouble up until apparently I'm almost 40 years old. Holy fuck, I'm old. I'm really tan. I'm looking at myself right now on the screen and I'm like, Donald Trump, the fuck? But in my defense, I live in Alaska. I live in interior Alaska. And I spent every single second of every minute with you motherfuckers on the lake. So... Tangle Lakes is the best. Quartz Lake was dope. Lost Lake was cool. Harding Lake is awesome. Chena Lakes has a lot of things go wrong there. So just life jackets. Wear a life jacket. Wear a lot of protective gear. Foreshadowing. I love you and I miss you and I'm so proud of you. You're 15 and you're going for a math degree. I'm 37 almost and going for a math degree. So, fuck. It's in like 3 months I'll be 37. YOLO. Okay, so I imagine that you're in some kind of lesson on how powers of I are cyclic, meaning I to the 1 power, I to the 2 power, I to the 3 power, I to the 4 power, I to the 5 power, I to the 6, I to the 7, I to the 8, I to the 9, etc., 12, 16, 20, 24, all powers 4, multiples of 4 are going to equal I to the 4, they're all the same. So if you have I to the 20, I to the 21 is equal to I to the 1, I to the 22 is equal to I to the 2, 23 back at 24, which is a multiple of 4, and etc., etc. So this is actually really helpful. You see the little heart I drew? I burned myself and then I just drew a heart around it so it doesn't look so gross on the internet. So this is important and it's really helpful and it makes your life so much easier. But you got to understand what's going on first and then just accept it, have faith with it, and just don't think about it too much. Just let it in, let it soak in, because it is glorious. But if you overthink it or try too hard, you're going to get caught up in the syntax. Story of our mathematical life. Tell you what. Okay, so let's go over what I means and what the powers of I represent and all that. So we have I, which equals the square root of -1, and we have I squared, which equals -1 squared, right? I squared, 2 i's, I times I. I cubed, the square root of -1 3 times. I times I times I. I4, you're going to have 4 of those babies. Okay, so that isn't anything new to you, and it shouldn't confuse you. But it does, I bet. I bet seeing the eyes and you're just like, ah! But just keep in mind, I is just really short notation for the square root of -1. Okay? So I squared is the square root of -1 times the square root of -1. Anything squared is itself times itself. I times I. I cubed, 3 of them. I4, 4 of them. Okay? And remember, it's the square root of -1. So keep that in mind, that I means something. It means the square root of -1. So if you ever get into trouble, follow mathematics. Okay? So we're going to talk about radicals. And what does mathematics say about squaring radicals? Okay, so let's talk about powers for a moment and ignore I. We're just going to talk about how powers work the way that you're familiar with them. Okay? So the way powers work, you're going to have some number, whatever it is. It could be 16, you know. We're going to call it A. It could be anything. So here will be my example, and here will be my general. You can stick any number you want for A in there. Any number you want. A -1. Foreshadowing. You can stick any number you want as the base. So let's just stick 18 for fun. So when you have A raised to a power, you'll multiply A that many times. So if our A is 16 and our power is 4, we'll take 16, 16, 16, 16, and multiply those 4 times each other. That is what 16 to the 4th power is saying. 16 to the 4th root is saying something different. And so if you see a fraction, the bottom number is the root. The top number is the power. So if it's a 1 in your fraction, it's just to the 1 power, A to the 1 power. When you see a 1, this could also be written like that. This is the power, this is the root. But if it's just a 1, we know how that works. So 16 to the 1/4, I'm saying something times something times something times something itself equals 16. Okay? We can rewrite that as this. And of course the answer is 2 times 2 times 2 times 2 if you work in computers. 2 times 2 is 4 times 2 is 8 times 2 is 16. So you could also write 2 to the 4 power equals 16. But when we're asking for 16 to the 1/4 power, it is saying what is my 4th root that gives me 16. If we were to take the square root of 16, it's saying what times what equals 16. And that's 4. 4 times 4. 4 squared is 16. So you can see my 16, if I'm finding what to the 2 power. What to the 2 power gives me 16. Here I'm finding what to the 4 power gives me 16. Something, 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 something to the 4 power will be 16. It happens to be 2 here. Something to the 2 power. So that's how roots work. And so if we have A to the x over y, it's really saying the yth root to the x power. So that's how this works. That's the syntax for that. So let's put this back up over here. We have some number to a power. This is power, this is root. So you're given the square root of -1. Well, my base is -1. My A is -1. So I'm just going to write -1 as my base. This is a 2. It's the square root. So I'm going to put 2 in my root denominator. Root denominator, root. This is a 2 there. We don't write the 2 there because it's weird. We know it's a 2. But you might see a 3 or a 4. And that's -1 to the 1/3, -1 to the 1/4. So these are roots. And squaring is multiplying. Root is taking the square root. Okay? So let's go back to the -1, to the 1/2, because I just really want to solidify that. -1 raised to the 1/2 is the same thing as -1 with a root of 2. Something times something equals -1. What is it? Yeah, there's no such thing, and that's why it's called imaginary. But when you get into engineering and physics, they don't care about your imaginary status. Some real fucking shit, and it's gonna have some real fucking consequences. If you think it's imaginary, you're gonna be electrocuted, or you're gonna hit yourself in the head with a projectile. So on that note of I in the fact that it represents something weird, I mean, what times itself will give us -1? I mean, multiplication doesn't, those are boobies. Sorry. Something times something is gonna give us -1. Those are still boobies. They're just weird. I always see boobies and everything. Probably because I don't have any. Oh, look, it's my bra size. Okay. So A times A, some number A, is going to give us -1. Well, you can't multiply a negative number times a negative number and get a negative number, and you can't multiply a positive number times a positive number and get a negative number. There is no number you multiply by itself to get a negative number, and yet here we are. Why are we here? This is some bullshit. And the reason is because, yay, physics. Physics is so awesome. So we have this guy, and he's starting here, and he's going like 5 miles, and then he goes back this way, and then he goes back this way, and then he goes back this way. Well, you want to represent that. So when he goes this way, you'll call it positive, and when he goes back, you'll call it negative, and when he goes this way, and then that way. So we're representing things going left and right by positive and negative. It doesn't mean negative as in the opposite of positive. It means negative as in the opposite of right. So it's kind of like when you're looking at chemistry and you have electrons and protons and they're positives and negatives. They're not. They're opposites. They're opposites represented by positive and negatives so that you can see that they're opposites. It's modeling. It's representing something. But dear God, it's representing something real. Don't let the math trip you up, or the fact that it's imaginary. It was called imaginary because back in the day, people were fucking stupid. So this is representing real phenomenon. And so when you're going back and forth, you're going to have negatives and positives. So when you have a parabola, this is a negative parabola, it's x squared. So if you're trying to solve for things, you know, it's going to be involving some negative squares and weirdness, and same with electrical engineering. Current's going that way, current's going that way. You're going to have some capacitors, and you're going to need to understand, they're going to graph things where your real axis is x and your imaginary axis is y. These are real things that are happening. These are real phenomenon, and if you misunderstand that, you're going to electrocute yourself. You're going to die. So understand that y may be, or y, I may stand for imaginary, but it means the opposite of that. That's what it means. It means the opposite. So an opposite direction is usually what we're dealing with. Okay, so keep in mind that last example was very brief, and I didn't get into electrical engineering or physics or where this stuff is going to come up. I just want you to know that it's representing something that actually happens. So wrap your mind around that these are numbers. You're dealing with numbers, okay? You're dealing with something happening. And I keep using phenomenon to mean plural, and I'm sorry for that. Oh, do you like my petty, no, this is a mani. Sometimes I'm not a girl. So I like have green marker. I had ADD and I just want to close. Anyways, sorry. It looks like I have dirty fingernails. It's just the look I was going for. It's gardener chic. And I don't know. I just felt like taking this green marker and giving myself whatever. You needed to know that. So back to the lecture at hand. Perfection is perfected, so I'm gonna let him understand from a young G's perspective. And before me digging a bitch, I got to find the contraceptive. You never know, she could be earning her men and learning her men, and at the same time burning her men. And you know I ain't with that shit, Lieutenant, because ain't no pussy good enough to get burnt while I'm up in it. And we can just skip the lesson right now. And fuck math. That is the lesson. Don't fuck raw dog. Okay? Don't. No. 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 You have like 8 sisters that you know of, and this is I don't know what we were talking about, but this is the lesson. This is the lesson. Okay, so back to the less important lesson, and I want to throw this back out here for you. Raw dog, negate that shit. No, don't do it. Okay, don't have sex without a condom is what I'm saying. This is what happens when you have your mom tutor you, and your mom is a fan of Snoop Dogg. Anyways, so back to our lecture. Something times something equals the square root of -1. The fuck? So let's take an example. So let's do the square root of -32. Okay? So what I always do when I see this is I immediately pull out the square root of -1. I immediately do that. Okay? That just makes everything simpler for me. Pulling out the square root of -1, I'm just going to call that I. We know that the square root of 32 can be rewritten as the square root of 16 times the square root of 2 from our previous examples. So we can take the square root of 16, which is 4. Ever since Pythagoras, man, the square root of 2 is a fucked up thing that gives people stress. Don't worry about it. Call it the square root of 2. It's not 1. It's not 2. It's somewhere in between there. Closer to the 2 side of things? I don't fucking know. Graph it. So we have our I. I times 4 times 2. 4i times the square root of 2. Let's do another example. Do 84. I don't know what's going to happen here. So, of course, the first thing we do is pull out a square root of -1. Always, when you see a square root of a negative number, pull out the square root of -1, and it will make your life better. So, what is that? 4 times 21? And so we can pull out the square root of 4, and we're left with the square root of 21. That's just I. Well, we know the square root of 4 is 2. We have the I, square root of 21. So the key is to pull out I. And then you're just left with a problem that you know how to solve. Okay? Okay, so back to this baby. Why does this help so much? Well, we understand what I is, so let's talk about what happens when we take i's to certain powers. So I is -1 raised to the 1/2 power. Okay? Let's make sure we can see that. So I is -1 raised to the 1/2 power. Square root of -1. All right. This is all the same. Okay? But writing it like this maybe will help you see what's going on. So we have I. You fucking thing, stop it. Stop, die. Except she killed a spider. Okay, I killed a spider. And a bug. What the fuck, house? Okay, so I squared is I times I. Okay, well, I is the square root of -1 times the square root of -1. And so, I don't know if you remember me teaching you this, but if you have the same A under your root, so we have -1, -1. When you square a square root, you're saying -1 to the 1/2 squared. When you do that, the radicals cancel. You're undoing something. Squaring something and square rooting something, you're taking the opposites. You're going to end up with -1, and which is clear if you remember when you're doing powers to a power, you multiply. We could rewrite it -1 to the 1/2 times -1 to the 1/2. And if you're multiplying, you add these. If you're powering, you multiply them. But either way, 1/2 plus 1/2 is still 1, you know? And that's going to be 2/2. You're multiplying 2 times 1/2, 2 times 1/2. And 2/2 is just 1. So we just found out that I squared is I times I. And when you have the same base and you're taking a radical with √2 times a power, √2 times 2 power, they can cancel. This just goes away if this is the same. And so I squared is just -1. So that's dope. I don't know where my little thing went. Found it. So I to the 1 power, I to the 1 power, square root of -1, or square root -1. I to the 2 power, we'll take 2 of these, and when you see the radical times the radical, and it's got the same a, it's just a. I cubed is 3 of them. Well, we know what 2 of them is -1, and -1 times the square root of -1 is negative square root of -1. Now, anytime we see the square root of 1, we can call it -I if we wanted to. So -1 to the 1/2 square root of -1, we're back at I. So that was pretty clear. I to the 1 is just I. I to the 2, it's -1/2 squared, -1, 2/2. 2/2 is 1. -1 to the 1 power is just -1. So if you didn't see how that worked, that's how that works. But it does just disappear. You cancel them out. You're taking the root of something and then you're squaring it. You're undoing the operation. You're left with just what you started with. So the radical, it just goes away. So that's just -1. This is the square root of -1. It's I, okay? And you could say -1 to the 1/2 is I, and you'll get -1 to the 1/2. These are all the same way of saying I, -1 to the 1/2, times 1 more, because we have 3 of them. So we had I squared, which is just -1, and 1 more, it's negative square root of -1. Okay, so the -1 came here, and then we had 1 extra I. -1 was from these two. I cubed is 3, so these two, just -1, times 1 more. You can write it this way, you can write it this way, whatever you want to do, whatever helps you figure out the manipulation, but -1 times the square root of -1 is negative the square root of -1, and you can just write -I. They mean the same thing. I4, you got 4 of these babies. This is my favorite one. I4 is my fucking favorite one. Yay, I4, because it's 1. I mean, just think about it. -1 times -1, negative times a negative. Well, that's great. So I times I times I times I is just 1. Okay? So I to the 1 power is I. I to the 2 power. I to the 2 power I to the 2 power. Radical times a radical. You're just left with what's under it. -1. And just remember that's I squared. I cubed. 3 of these bad boys. So we have 2 of these bad boys is -1 times 1 of these bad boys is an I. Okay? We have negative square root of 1. Sorry. Negative square root of -1. Fuck my life. Is -I. -I. And my favorite, I to the 4 is fucking 1. I love you. This one is my favorite. Hello! I love you. So it will always go like this. The I to any power, because we talked about this in the first video. I1, I2, I3, I4. Let's look at I5, okay? So I5, it's square root of -1 times I4, right? That's 5 i's. Square root of -1 is just I. 5 of them. I've got 4 here. I times I times I times I times square root of -1 is I times I times I times I times I. These are the same thing. Use them interchangeably as you will, so you get used to them. I is the square root of -1. So I have a square root of -1 times I4, but we remember that's 1, bitch! So I5 is just the square root of -1. I6 equals, well, we have I5, and it's the square root of -1. Well, I5, we figured out, was the square root of -1. And when you got the square root of -1 times the square root of -1, you were back at -1. You undid your operation. You're back. So I6 is the same thing as I squared, which was -1. I. -I. And my favorite, I4 is just 1. That's the fucking most awesome. Okay? So I7 is going to be I6 times I. Ignore that. That's not a thing. Ignore me. I'm going to switch colors because I'm running out of ink here. I'm wasting these $50,000 markers I got for you spoiled ass millennial entitled fucking hipster sister. Sorry. I to the 6 times another I. That's I to the 7. Well, I to the 6 was -1. -1 times I. -1 times the square root of -1. Negative square root of -1. Holy shit, we're here. And I bet you I to the 8 is going to be 1. Because it is going to be I to the 7 times -1, and we had negative square root of -1 times the square root of -1. The square root of -1 times the square root of -1 is just -1. And we negate that, and we're just left with 1. So I to the 8 is I4. So I to the 9 is just going to be the same pattern. So I've got I8 times the square root of -1. Well, we know that that's 8 is I4 times I4, right? When you have them same base, the powers add. If you were doing I to the 4, the powers would multiply. But we're doing I4 times I4, base 4, base 4. They add. I8. I4 is 1. 1. So to the 9 is I8s, which is 2 I4s, which is just 1. You're left with -1. So the cycle just keeps repeating. You will always repeat. And so that the key is to pulling out some form of I to the power of 4 so you can see what's left over. And by seeing what's left over, you can figure out the answer. We have arrived. We're at the point where I'm going to not answer the question you gave me, but answer a similar problem, show you how to do it, and you're going to get the intuition behind what you should be looking for and solve the problem yourself. So we talked about this. I to the 1, I to the 2, I to the 3, I to the 4. I, -1, I, 1. I, -1, I, 1. I, -1, I, 1. Okay, it does it forever. So I to the 1 power, I to the 2, I to the 3, I to the 4 is 1. Then I to the 5, you go back here, it's equal to I to the 1. I to the 6, you go back here, it's equal to I to the 2. And we've shown that. So you're looking to get your problem. So for our example problem, let's do x to the 87, okay? You want to get your problem to x times 4 times some multiple, and then whatever's left over, and it's going to be 1, 2, 3, or 4. It's going to be x to something. It'll be 1, 2, 3, or 4. And that's the goal, is to separate out all the powers of 4, or multiples of power of 4, and then see what's left over, and it will be 1, 2, 3, or 4. It will be a power. And so let's illustrate this. So we have x to the 87. Well, we know 84 is a multiple. And remember, when you have base times a base, you add them. Okay? If you were doing it like this, that is something different. You're multiplying them. I know what I'm doing. So they're different operations. So this times this, you add the exponents. This, you're multiplying the exponents, okay? So don't get confused. So you want to take, again, we're going to take x, our original equation, we have x to the 87, and we want to convert it into 4 times some power an even way, and then whatever's left over. So 84 is divisible by 4. We can rewrite that as 4 times 21. And then what's left over is x to the 3. Any multiple of 4, as long as it's even, and by even I mean not a fraction, as long as it's an integer, I guess a positive integer. We're just looking for multiples of 4. And so we can pull all that out as 1, right? Because we're just going around 21 times. This is x to the 4, 21 different times. Well, it doesn't matter how many. I can go 80 times. I can go 1 time. I can go, as long as I'm going 4, that's 1. And so what's left is x to the 3. And so you should get that this is, well, x to the, or an x is I. So I to the 3, negative I. Negative square root of negative 1. I just call square root of negative 1 I. You can do whatever you want. And we've shown that in the earlier videos. So let's do another example. X times 65. I don't fucking know. So again, we want to convert this, and I keep saying x. So we're dealing with I. Can you go to the park? What time is it? With me? Yeah, as soon as I'm done with your sister's videos. Why do you need caramel? Why are you just chewing on a closed bottle of caramel? Come say hi to your sister.
Where is she?
She's on the video. She's on the internet. Say hi. All right.
I don't see her.
She's not online. I'm making a video that she's watching.
Right now?
I'm recording, and you're on the recording. When I send this to her, she's gonna watch it. So she'll see you on the video, but she's not there now. I mean, okay, so she's watching the video, so she is there now as she's watching this. However, she's not watching it while I'm recording it, so she's not there. This isn't Skype. I'll take you to the park. But let me finish. So I to the 65. We want to get that to some multiple of 4. So I to the 4, this 1, and then 24, 6. Is that right? 4 times 16 is 24, 4, 64. So we've got 1 left over, and that's just I. So remember, this is a perfect multiple of 4. It goes around 16 times. It's 1. So what we're left with is just I, or square root of negative 1. Let's do another one. I to the 73. I could do this all fucking day. So 73 divided by 4. I know how to math. 8, and it's a remainder of 1. It's a remainder of 1. It's a remainder of I to the 1. So again, we are looking at I. And let's ask Google. Google. Yes, you can go. But you only have 30 minutes, and then come back. Can she come over here? What are you asking? I thought you just said she can't go to the park. With me? Are you asking, can she go with me to the park? Yes, can I finish this fucking video? Please? Oh. I thought you were asking me. I was like, I already asked you. Told you the answer. Now let me tell your sister the answer. What is I to the 73rd power? I.
I to the 73rd is I.
Yeah, we knew that. Check this one. I to the 65th power. It's I. What is I to the 87th power? What is I to the 87th power, Google? What happens when you have your neighbor's internet and it's all fucking slow? What is I? No! What is I? Damn it! What is I was already answered. What is I to the 87th power? I can't do this. Okay. What is I to the 87th power? What is I root 87? Is this going to tell me? Google can't answer me. What is I to the 87th power? I'm going to shoot myself. This internet is so slow.
I to the 87th is I.
That doesn't say I. That says negative I. What the fuck? It's negative I. And we got that. That says negative I. You can't see it. It definitely says it. Google, you gave me the wrong answer, but you wrote the wrong answer. It's negative I. Yep, we got all of these right. Negative I, see. Negative I. I got this right. Google voice is not reading the answer on Google. And that is technology. And that is why you need to be a robust programmer. We're going to get into that on another topic. You're a math major. You probably won't get into robust programming. You should, though. You should get into robust programming. It bothers me. Think about military time and idiots and how they'll type in negative numbers for their birthday. Or people like me whose touchscreen goes out of control because they eat Popeyes while they're on their phone. Or it's cracked. Oh, hell.